Hello, welcome to section 4.2, solving square root equations. Our essential questions are, what is a square root equation? What does the solution of a square root equation represent graphically? So we talked about square root equations in section 4.1, well, functions, the graphs. And we looked at transformations and how to graph them and whatnot. So today we're actually going to be solving equations. The first note card is move my face, is note card 88, and it's the steps to solve a square root equation. Okay, so the first step, isolate the square root expression. Second step, square both sides. Third step, use algebraic rules. Using algebraic rules, simplify each side. Fourth step, solve for the variable. And the fifth step is to solve for extraneous solutions. So pause me and finish up note card 88. I've used the word extraneous before, but we really need to get into the nitty-gritty of what is an extraneous solution. So note card 89 is about extraneous solutions. Extraneous solutions are solutions that are derived when solving a problem, when we're doing the work, we're doing the algebra, we're doing it, but the solutions do not work in the original problem. So I'll bring an example right here. Okay, so if you look right here, we have the square root of 2x plus 1 equals -3. Now, I know I haven't gone over examples on how to do this yet. That's next. But what you would do is you'd square both sides. You just had the note card where you wrote that down. And you get 2x plus 1 equals 9. You solve like normal, and you get x is 4. You think all is great in the world. You're doing delta math. You put 4 and you get it wrong. You're like, what? Then you need to look at the solutions. And you're like, oh. See, if I put 4 back in the original problem, I have the square root of 2 times 4 plus 1. And you're checking, does it equal -3? That's why I have a question mark there. That'd be the square root of 9. Does that equal -3? 3 is the square root of 9, and it does not equal -3. So no, no, no. This is called an extraneous solution. And so overall, this original problem has no solution. Pause me and finish up note card 89. All right, now we're going to move on to note card 90, where we're doing an example of solving a square root equation. We're actually going to do an example. So we're going to solve this one. The square root of 110 minus n equals n, and we're going to have to remember to check for extraneous solutions. Okay. All right, so what am I going to do? Well, step one, we need to isolate the radical expression, which it is. It's by itself. Like if there were a +1 out here or a -3, I'd have to get rid of it. But it's by itself. So I go and I square both sides. Now, when you square root, when you take the square of a square root, it just negates that square root. So we're left with 110 minus n equals n squared. All right, so then we have a quadratic and we have to go back to unit 1. How do we solve a quadratic? We need to get it in standard form. You want that leading coefficient to be positive, so I'm just going to toss both of these over this way. So I get 0 equals n squared plus n minus 110, because I'm tossing to the other side, changing the sign. Now, if that drives you crazy, just write the equal 0 on the right side. You wouldn't have to do that, but go ahead. Let's factor this. What times what equals -110 but adds to give you 1? That would be 11 and -10. And guys, if you're not comfortable with factoring, which you should be, but if you're not, you could always use the quadratic formula or complete the square. I ZPP this. I set each of these equal to 0. I get n equals -11, and I also get n equals 10. I need to check for extraneous solutions. So my original problem was the square root of 110 minus n equals n. So now I'm going to go and check my -11. Because I got to plug -11 back into both of the n's. This gives me the square root of 121 because that turns into a plus. I'm trying to see if this works. That's 11 equals -11. That is not true. So the 11 is an extraneous solution. It does not count. I'm going to use EXT. So that 11 is an extraneous, oh, you can't see through my face. That 11 is an extraneous solution. So I'm going to go over here and go like this. All right. Now let's check the 10 in the original problem. So I'm checking the 10. 110 minus 10 would be 100. Square root of 100 is 10. And we